Hello everyone. Thank you for attending this presentation. My name is Naoya Tanimura. I'm in charge of developing reference hardware at Panasonic. Today, I'd like to talk about getting close to real automotive product with AGL reference hardware. This presentation will take about 30 minutes. Here is the agenda. Firstly, I talk about history of AGL reference hardware. Secondly, I'll explain the welding image process for reference hardware. Thirdly, I'll introduce AGL developer tools. Then, I'll show device virtualization as case study. Finally, I make a conclusion. There will be time for questions at the end of presentation. Let's move on to history of AGL reference hardware. AGL is an open source project for the purpose of building Linux-based open source software platforms for automotive applications that can serve as de facto industry standards. AGL supports all kinds of in-vehicle software, such as in-vehicle infotainment, clusters, and head-up displays. Adopting a shared platform across the industry reduces fragmentation and allows automakers and suppliers to reuse the same code based on Linux, which leads to rapid innovation and faster time to market for new products. AGL allows you to build images for a variety of supported hardware targets, including reference hardware. Reference Hardware System Architecture Expert Group was founded in 2017 for the purpose of building a hardware platform, which is used prototyping according to various requirements in automotive industry. At first step 1, General Purpose Development Board was used in AGL community in order to develop UCB and do AGL demo. Next, in step 2, more users, including Tier 1 and Tier 2, institute, OEM increased. More use case increased. These use cases include OEMs installing the system in their vehicle for more realistic demonstrations, conducting POC of the product according to each required specification, and evaluating the system feasibility. So the expert group started discussing the concept of reference hardware, which features interchangeable architecture with general interface and standard 2D size for vehicle mountable. AGL reference hardware is an ecosystem designed to provide a basic targeted to in-vehicle infotainment system development. The SOC used on this hardware sample is RHSA-EG Renaissance Electronics Corporation. This is promoted by Reference Hardware System Architecture Expert Group in AGL and Support AGL project. Each function board is divided and interchangeable for your own system, so anyone can develop software quickly. You can rapidly build prototype and explore features with AGL. There are specifications of AGL reference hardware. Reference hardware is divided into 3 major boards as this block diagram. At first, control board, because the SOC is on this board. So this block is related of all functional blocks. The design of high-speed interface is done with this board to increase the reliability of the hardware. Secondly, audio board, which can adapt to variety of audio and radio requirements. Audio and vehicle have common interface, so it is possible to connect the control board and both board, or just the audio board. Thirdly, vehicle board, which can adapt to power control requirement variety. The other small boards are functional board which has various interface. Each board is interchangeable according to the requirements for demo or prototype. Here is a specification of full custom. Reference hardware has Renesas Arca H3 and 64 GB ROM storage and 8 GB RAM and some external interfaces. This hardware can also support in-vehicle interfaces such as CAN and RIN. This figure shows three mechanical features. First of all, each board has a mechanical strength. In the case of mounting on a real car, the bonding strength between the substrate is required, but the connector alone is not sufficient. This hardware has screw hole, so it is possible to enhance enough strength. Secondly, cable can be connected in one direction, so that this hardware can be mounted on a real car easily. Thirdly, the reference hardware can be matched to the OEM connector for each function board within 2D size. For more information on the AGL reference hardware, please refer to the expert group wiki. Several documents are up there. The reference hardware manual contains the hardware specifications, and the design guideline contains design information for each board. So you can design your own board if you want. In this way, the groundwork has been laid for the development of the AGL community as a whole. Let's go on to the next topic. I explain how to build an AGL image for reference hardware. This figure shows the AGL software architecture. The AGL unified code base called AGL UCB consists of 5 layers. The app and HMI layer contains applications with their relevant business logic and HMI. The Yacht project makes it easy to customize the build to the AGL image for the target machine, including the reference hardware. This architecture further helps reduce development fragmentation and accelerate process innovation. Yacht project is an open source collaboration project that helps developers create custom Linux-based systems regardless of the hardware architecture. Kooky is a reference distribution of the Yacht project. It contains the open embedded build system as well as a set of metadata to get you started building your own distro. Bitbake is the most significant open embedded build system component. You can git to clone the Kooky repository and bootstrap your own distribution. Here is the AGL schedule and milestones. AGL unified code base is updated semi-annually. And now, Kooky Koi is the latest version and is recommended. You can check release status in wiki page. This AGL image development workflow consists of setting up the build host that builds the image and finishes with using the yoked project to create an image targeted towards specific hardware. First of all, you need to prepare a build host that meets the required specifications. Secondly, download the AGL software. Then, initialize the build and customize for target machine like the reference hardware. Finally, build your image by bitbake as a bit engine of yoked project's component. I'll show this reference hardware build step from the next page. To begin with, you need to download the repo launcher and ensure that it's executable. Then, download the AGL source files depending on your developing targets. In this example, I used Kooky Koi version 11.0.0, which is the latest version. And it is recommended that you download this version. To check the release note, please refer to the wiki. Once you sync the repository, you get the AGL files in the form of layers. The AGL reference hardware is based on the same Renesas Arcar HC processor used on the Renesas Arcar starter kit and Salvatore X board. So, support for it leverages the starter kit known as H3 USB build. Before setting up the build environment, you need to download appropriatory drivers from the Arcar H3 software site. Run the setup packages shell script as follows to display the list of zip files containing the drivers you need. Then, you download your appropriate BSP version and check the correct access rights. Prior to initialize the build environment, define the machine variable for the reference hardware as H3ULCB. Then, initialize the build environment by running the AGL setup shell scripts with the machine name and feature setting as arguments. By including AGL reference hardware H3 in the feature settings, reference hardware's recipe are included in build target on local conf. Once you initialize, some configuration files is created in build directory. Because the build process is based on bitbake and yoked project, build customization are driven through configuration files used during the build. Lots of configuration files exist that define a build. However, the primary one that acts as a global configuration mechanism is a local conf file. In addition, the BB layers conf file define layers, which are directory trees traversed by bitbake. The BB layers conf files use the BB layers variable to list our layers bitbake trees to find. There is an additional note about BB layer. The latest version Kooky Koi solved this problem, but if your build failed due to GStreamer because of old version, it is possible that yoked project move on to more latest version. In this case, Jira spec 3706 might help you. This code in BB layer conf file just explained and rename related files as this. I was able to avoid the build error by this way for version 10.93.1. After customizing the build, use Bitbake to build the AGL image. In this example, we are building an AGL demo platform image that includes a demo and other features. The first build will take roughly a few hours, depending on your CPU and network environment. When the build completes successfully, the image will be stored in the build directory. Flashing the image on microSD card. Prepare the microSD card with over 16 GB for free space and plug your build host. For example, you can use the lsbar command to display the recognized block device tree. Once you have identified the microSD card, you can use bitmap tool to copy the image to the microSD card. Alternatively, you can leave the image in an uncompressed state and write it to the microSD card. Once you have the AGL image, you need to prepare the peripherals to run the reference hardware. The main peripherals are included in the package. In addition, you will need a standard micro USB cable for debug. A power harness, an AC adapter, and a USB cable for debugging are sufficient for the minimum demo operation check. The micro USB cable should be connected to the host PC as shown in the picture. On the reference hardware side, console is printed on the board near the connector. The baud rate is set to 115,200. Insert the boot microSD card into SD card 0 connector, as shown in this figure. Do not accidentally insert it into SD card 1 connector. Next, turn on the power. The fan will start spinning and U-boot will start booting. The real machine has its internal building set to Salvatore X, so the configuration defined for Salvatore X can be reused. On the other hand, the DTB file used for the reference hardware is RHSA-7795 AGL reference hardware DTB file. Thus, the U-boot configuration will look like this. When you power on the system, you will start booting and the kernel will boot. When prompted for a password, type root to log in. After successfully booting, you will see the demo home screen as shown in this figure. From this GUI, you can launch applications such as the browser, dashboard, and media player. The AGL demo images requires Full HD monitor. Using a monitor with a different resolution may result in a broken GUI layout. These photos show the inside of the 630 exhibited at the Mazda booth at CC 2020. Mazda installed a reference hardware in mass-produced vehicle and demonstrated how to operate the infotainment system from the operation device in the driver's seat. Reference hardware has mechanical strengths that can withstand the in-vehicle environment, and you can easily build the hardware that meets your requirements because of interchangeability. In addition, you can easily build an OS by using the Yoked project. As you build the demo image according to the procedure shown in this presentation, as shown in this demo, we believe that early prototypes on mass-produced vehicle using the reference hardware can contribute to the early identification of issues. For Wi-Fi Bluetooth features, the function board and peripheral are ready. The Wi-Fi Bluetooth driver for TI module will work by applying a patch to the latest version of Kooky Koi. The upcoming documentation will include hardware manuals and installation procedure. The hardware manual also describes how to assemble. External antennas that meet the requirements of the module are included in the offering. For details on how to update, refer to the wiki that has a dedicated page for reference hardware. Please update if necessary. Next, I introduce the various development tools operated by AGL. AGL uses Jira for defect and project management. Defects are submitted to automotive-grade Linux using the bug issue type. Once a defect has been submitted, it will be assigned to the appropriate developer for review and possible fixing. When you face a problem, please refer to Jira and check if there is a related bug issue. You can also register a new bug issue. AGL community members collaborate through the Gerrit review system. This system also manages other progress such as source code review, build availability, and test status. Registered users of Gerrit can fetch repositories and participate in reviews. These are AGL communication channels. Generally, the AGL main group will be used only for announcements of interest to the entire AGL community. If you are interested in technical discussions, including reference hardware, have a question or just want to meet some AGL developers, please join the subgroup AGL Dev Community. If you work for a company that is an AGL member, please join the member group. Conference is a workspace for AGL teams. If you would like to check the latest activities or contact the person in charge, please visit here. You need a Linux Foundation account. Next, I introduce example of virtualization applications using AGL reference hardware. The AGL reference hardware is not only designed for non-virtual use case. It is also applicable to virtual use case, which has been a trend with increasing need of ECU consolidation. Based on AGL reference hardware, but I/O enabled virtualized AGL POC from VAT-EG member Open Synergy, which highlight two significant features of the combo of AGL reference hardware and VAT-IO. One is easy updatability, which means upgrading OS version of virtual machines can be easier and faster. The other benefit is easy switchability. With a combo of AGL reference hardware and BAT.io, OEM and Tier 1 can easily change SOC, device, and hypervisor, which will highly enhance the portability of software assets. For details, please visit OpenSynergy's technical session in this AMM with the title of Obtaining BAT.io Engable Virtualized AGL KK Reference Demo Distribution. Our conclusion is the following points. The AGL reference hardware can also support in-vehicle communication interfaces, and its interchangeable features allow you to immediately build prototypes that are close to the actual product, which can be used for POC and demonstrations. You can build efficiently by using Yokt project. AGL help you explore AGL through open source and community channel. If you consider the purchase of AGL reference hardware, please contact us. Thank you for listening. Finally, I'm happy to answer your question now.